In this chapter, we are talking about atoms, molecules, and ions. Although the concept of atoms had been around since the time of the Greek philosophers, it wasn't until John Dalton came along that there was any experimental testing related to atoms. Based on his testing, he came up with 5 key ideas or postulates. His first postulate is that everything is made up of atoms. Secondly, elements have only one type of atom. For example, copper is made up of copper atoms. Thirdly, elements have different properties. For example, copper has a different color from other metals. Dalton's fourth postulate is that compounds have fixed ratios. For example, there is a compound called copper 2 oxide, which always has a ratio of 1 copper to 1 oxygen. If it had a different ratio, it would be a different compound. His fifth postulate is that atoms are not created or destroyed in chemical reactions, only rearranged. For example, in the reaction between copper metal and oxygen gas, the coppers all start out next to each other, and the oxygens start out next to each other. But by the end of the reaction, they end up in a copper-oxygen arrangement, spreading out in 3 dimensions. They are rearranged, but the atoms themselves are the same atoms as at the beginning of the reaction. Thinking about Dalton's postulates, does this drawing violate part of Dalton's theory? The answer is yes. It shows 2 greens and 2 blues at the start of the reaction, but only 1 green and 1 blue at the end of the reaction. This would violate Dalton's fifth postulate, which says that atoms are not created or destroyed. Does this drawing violate part of Dalton's theory? The answer is no. All postulates are followed. For example, there are 4 greens and 2 blues on the left of the arrow, and 4 greens and 2 blues on the right of the arrow. Along with his 5 postulates, Dalton came up with 2 laws, the law of constant composition and the law of multiple proportions. The law of constant composition, which is also called the law of definite proportions, tells us that all samples of a pure compound contain the same elements in the same proportion by mass. In this example, we have 3 samples, A, B, and C. All 3 samples are the same type of compound containing carbon and hydrogen. Each sample has different masses compared to each other, but the carbon to hydrogen mass ratio is the same for each. To find the mass ratio, I take the larger mass divided by the smaller mass. In this case, the mass of carbon in the sample divided by the mass of hydrogen in the sample. For all 3 samples, we get a 5.33 to 1 ratio of carbon to hydrogen. If you were to analyze some unknown samples and find that they have the same mass ratios, they would likely be the same compound. It turns out the reason compounds have constant mass ratios is that they have constant ratios of the number of each type of atom. However, we can test masses in the lab much more easily than testing number of atoms. The law of constant composition deals with the masses in samples of one type of compound. The law of multiple proportions deals with the masses in samples of 2 or more related compounds. For example, it deals with the masses of the elements in copper 1 chloride as compared to the masses of the elements in copper 2 chloride. It tells us that when 2 elements react to form more than one compound, a fixed mass of one element will react with masses of the other element in a ratio of small whole numbers. This again will be because the ratios of the masses are related to number of each type of atom in the chemical formula. Copper 1 chloride has a 1-to-1 ratio, whereas copper 2 chloride has a 1-to-2 ratio in terms of their atoms. The mass ratio of copper 1 chloride will end up being twice as large as the mass ratio of copper 2 chloride. This example shows you how you would do the calculations to show that these 2 samples follow the law of multiple proportions. In both samples, we divide the mass of oxygen by the mass of carbon to get the oxygen to carbon mass ratio. For sample A, we get 1.33 to 1, and for sample B, we get 2.67 to 1. Since these are different mass ratios, they must be different compounds. They are related, though, because they both contain only carbon and oxygen. When we take the mass ratio in sample B and divide it by the mass ratio in sample A, again larger divided by smaller, we get 2, which is a whole number. This is because sample B has twice as many oxygens in its chemical formula. It turns out sample B is CO2 and sample A is CO. Here are a few conclusions we can draw from the law of constant composition and the law of multiple proportions. If the mass ratios in two samples are the same, the compound is likely the same. If the mass ratios are different, they are definitely different compounds. Masses of each element and number of atoms are related, which is why these laws work.